Welcome to part 3 of our webinar series on building hybrid cloud applications. Today, we're going to show how to build a mobile application using React Native. Our presentation will be by one of Murtec's developers, AJ Singh. Before we get into AJ's presentation, let's do a review of what we've already gone over in this webinar series. In part 1 of our webinar series, we went over how to build an API using Thriftly.io against an existing application stack. We used our property tracker demo that's included with Thriftly Developer to quickly create an API using Thriftly's function as an API ability. We were also able to publish that API out onto the internet using Thriftly's gateway services without any effort required at all. We were able to do it instantly. In part 2 of our webinar series, we showed how to take that same API and build a web-based front end against it using Angular. We used it to build what's called an SPA, or single page application. Now, Angular has this very MVC-like architecture that works quite well with Thriftly. And of course, it has many advantages all on its own. For instance, you have access to thousands of libraries that have been written over a period of years for Angular. Angular has been out for a relatively long time for a JavaScript framework, at least. And that means that it has this well-established user base, and it's also a very mature framework. This means that you can build rich, sophisticated UIs using Angular and Thriftly. And of course, we did just that. We built a property tracker application, web application, using Angular and Thriftly.io. Now, we're going to take a very similar approach in today's webinar. We're going to use that exact same API, and this time we're going to build a mobile application against it using React Native. Before we get into that, though, let's talk a little bit about some of the advantages that Thriftly provides in these sorts of application stacks. Normally, when you are building an API server, one of the things that you have to consider is how you're going to deploy that API server at your customer's site. Are you going to shift the customer into a cloud-based system, in which case you can just expose that API directly? Or maybe you're not able to do that because the customer needs to keep that application and especially their data on premises, or they want to keep it on premises. If that's the case, how do you go about exposing that API at all of your customers' sites without having to worry about having to configure firewalls and deal with network address translation and changing IP addresses and all of that? Well, that's where Thriftly comes in handy, because using the Thriftly gateway service, you're able to deploy an API on an automated basis at your customer site and have that API exposed onto the internet instantly. Thriftly includes not only an automation scripting language that allows you to make that deployment automatic with the software update, but it makes this whole idea of getting an API out onto the internet a trivial task to complete using our gateway services. This means that you can roll out just an application update that includes a full API server and allows for sections of your application to be exposed, or your entire application to be exposed onto the web or onto a mobile device, as we'll see today. Thriftly allows you to access that API from a myriad of different frameworks and systems that are in common use today because of the many protocols that it supports built in, without you having to do any effort to use whichever one is best for your application as well. So for instance, against a mobile application, maybe you choose to use a binary protocol or JSON RPC or SOAP or whatever the case may be. All of that is exposed through Thriftly without you having to do any work to define that protocol specifically for your API. This sort of hybrid architecture, where maybe part of your application is in the cloud, such as the web front end being published on a cloud server, but the API being on the customer premises, we of course call this our hybrid cloud architecture. But it means that especially for ISVs, you're able to support this system where your customer needs that data to stay local, but you need to manage that API server. And we're going to see that today in our demonstration with the Thriftly API for the property tracker system that AJ is going to build a mobile application against. That API is being exposed using this gateway service, as you'll see. So with that as a backdrop to what we're building against it, we're going to now get into this presentation, show you what React Native is capable of. After AJ's done with that presentation, we'll spend a little bit of time doing some question and answer, and we'll also show you what's coming in our next webinar as well. So now we'll turn things over to AJ.
Hello everybody, this is Amarjeet Singh, and today I'll be talking to you guys about React Native. A preview of what we'll be going through is what is React Native. We'll go ahead and see React Native in action by building a simple interface to the property tracker API. Then we'll go through some debugging tools and methods that we can use with React Native. And finally, we'll answer the question, why React Native? But before that, let's answer, what is React Native? Now, React Native is nothing more than a JavaScript framework. And we've seen this before with Angular, Vue.js, and even React itself. The difference between those and React Native is that React Native is used for mobile development. Now, with React Native, you can write your JavaScript code, and it'll get converted over to iOS and Android. The cool part about it is, because it's JavaScript, the web developers that are familiar with JavaScript and have third-party libraries that they like to use can feel comfortable writing React Native code. Now, React Native will actually translate that code. So let's say you use a text component in React Native. It'll get translated over to a text view on Android or a UI text view on iOS. So any developer who knows how to write React code can now target web, iOS, and Android. So let's look at React Native at a glance. So what I meant by the JavaScript code getting translated, that happens with the React Native bridge. So you write your code in JavaScript, and the React Native bridge will go ahead and communicate with each platform and translate your components to the OEM widgets. Additionally, using the React Native bridge, we have access to the camera, the sensors, and etc. So what are these components that I'm talking about that get translated over? So these components come in different layers. So this diagram over here to the right-hand side shows those layers. The lowest most is the reactive components itself. These are the components that come with React, the website. So after that, we have the React Native components that are native to the React Native library. These are components that cannot be used with React, but are used for React Native, as in mobile development. And then inside of that, we have your native components. Now, what your native components are is, let's say you have a particular list or a particular screen that is native to your application or a group of applications that you're developing. That can be your own specific component that you can pull out and reuse in multiple locations. Then you have your core components. Core components are like the text view, the image, the views, the stuff that comes baked in with React Native. And then following that are the community components. Community components meaning components that have been developed by community members. So such as, let's say you need to access the camera. So rather than writing all that logic or that code to access the camera, somebody's already done that. So you can go out, find that component, and integrate that into your application. Now, looking at this diagram over to the left, you can see that I have an image component and I have a text component inside of a view. But it shows right here how, even though I have that image component in React Native, on Android, it's going to be translated to an image view. On iOS, it's going to be translated into UI image view. Same thing with the text. So it gets translated text view. On iOS, it'll get translated to UI text view. So this right here shows that which components match to what components in their specific language. So what really helps with translating them is the JavaScript extension. Both React and React Native use the JavaScript extension. Now, basically what it lets you do is write those HTML elements and components in our case inside of your JavaScript code. In React, it'll go ahead and place them inside the DOM, but in React Native, we'll go ahead and see them get mapped over and display on the screen of your phone. So in this code snippet we see here, we have a text component. Now that text component is written inside of this JavaScript code. However, when this does get mapped out, it's going to be a text view on the screen. And we'll see that later inside of our demo, how these components get mapped over. So each component also comes with its own properties, props for short. Now, what these properties let you do is customize these React components. This code snippet here will show you that I have this cat component separated out into its own function, and I'm accepting props. Now you can see here in the main inside of this view, I'm rendering the cat component 3 times, sending different names to it. That's how props work. By using this dot notation, I can access that name. I can add additional variables to here. I can even send in functions if I need to use functions over here, and using the dot notation, I can access them. So each component will have its own settings, whether it be style or a specific way that the component needs to function. Same thing with community components. They'll have a specific set of settings that you have to set to it before you can use that component. That's where props helps you. However, some components need data. Props isn't really much data as it is customizability of that component. To data, we have state. State is where we store the data for that component or any data that that component is going to be used. And states are like your component's memory. Let's say you have a list, and the list has some data in it, and it's rendering that data. Let's say that list changes over time, whether it be by refreshing to the API or some stuff happened to the list where it's deleted, modified, etc. Well, that data needs to update. I don't want to keep showing that old data. That's where state comes in. I store the data of that list inside of a state, and anytime it changes, I update that state. That will reflect, without having to remount the component or re-render the component, it'll show me that change in that data. So as a general rule, props are used to configure a component when it renders. States is to keep track of data for that component as it changes over time. So additional to those three things, we have networking. Now, networking works different than as we saw in our Angular webinar. In Angular, we have to create a service to make those HTTP requests. However, in React Native, it's a simple function. React Native comes baked in with something called the fetch API. You could go out and look for third-party HTTP request libraries, and those could work much better for your use case, but the fetch library works for most cases. So as you can see in this code snippet here, I'm using the fetch to go ahead and make a call to this endpoint. Now this endpoint is returning me a JSON, and from that response, I can pull the JSON file. So this is how easy fetch is. It just works simply. Additional to the fetch, you can attach headers, you can specify which call it is, you can send parameters with that call, and various other simple things that fetch will need to do. Now, we've seen networking, we've seen how props and states are handled, the JSX, I've talked to you about components, but how does this all play together? So now I'll go through a little demo and I'll show you how all this is put together, and we can see it connects to our property tracker API. So let me switch over to my device right now real quick. All right, so here I have a application that I've built out. So we see a little button here that's going to lead us to the property list. This would be our home screen. Now the way that I've set it up is I want to show you guys navigation in React Native. So me clicking this button will lead me to a different screen, which will show me my properties list as indicated by the button, right? But what I wanted to show you is how easily it just swiped over, right? That's none of that logic is something that I coded in. I just told that button where to go based on it being clicked. This header that's being rendered, that back button that says home, that's all being done by the React Native navigation library. So let's say I can click into this screen. That 1, 2, 3 testing is now taking place of the header. Properties is the previous screen that I came from. So we also see this floating action button down here in the bottom right-hand corner. Me clicking this will show me more options. Add item. So if I go ahead and click that, we see a modal that pops up. I can fill in the information, save it, it'll get posted to this property. Additionally, we have this show item. So clicking that, you can see I swiped in to the new screen that shows me the items for this property. However, what I want you to notice is it says 1, 2, 3 testing at top where the back button is. Now, if I click that and I go to a different property who has a longer name, say this one, and I go to its items, see how it changed to back? That's all being handled by the React Native Navigation Library. By letting it know what screen you are, it could generate what it needs to show there up on top of the header, the app bar, and it'll have its own title. And you can customize this as well. And you can also see what I'm doing right here is gestures. This is something, if you're very familiar with iOS, that most apps integrate is slide gestures to slide back to the previous screen. This is all also integrated with the React Native Navigation library. I don't have to code this logic in to slide in to the previous screen. It's all being handled by React Native. I'm just telling it, hey, this is a screen I want to navigate to when I click this button. And by doing so, it automatically handles all that navigation. So this aside, let's go ahead and look at the code for this app. Let's see if we can try to build up to what I have right here. So I'm going to go ahead and switch over to the code. Okay, let's take a look at this initial application. This is what you are presented with when you have React Native create a new application for you. It's a welcome to React screen, and it has a couple of hyperlinks here that will take you to some documentation portions. Let's take a look at this code structure over here. And if you're familiar with JavaScript frameworks, you can see that this code structure looks identical to other frameworks. You have your package.json, you have your node modules, you have your index. Now, this package.json, if not many of you know, is where all your packages that are being used with your application are going to reside. So their version numbers and whichever packages they are. I like to handle my packages using npm, so I would like to install them, uninstall them, change their versions using npm. But it's nice to know that in this package.json, that's where you'll see what packages you're using. You'll be able to see what versions they're on and other settings for this application. So aside from that, what we have is index.js as our entry point. This is what will go ahead and tell us where we need to go furthermore. So we see that the app registry is pointing to this app component, and this app component is under the source folder. Now, when the initial application is created, that app.js file will be on the same level as index. Now, I've put it inside of the source folder because I have some other components and models alongside it. So a better way to clean my code up. And I've went into add index.js and pointed that the app.js is now under the source folder. So taking a look at what's inside of my source folder is obviously the first thing is that app.js, which has all the logic and code for this welcome to React screen that we see over here. Additionally, I have the models. These are the models that we'll be using in this application. The property model, the item model. We have the components that we'll see. We have our home screen. Now this is a screen where we saw that one button that led us to the property list screen. We have our property list screen. We have our item list screen. And then we have this list component. Now this list component is a shareable component that I share between the items list and the property list. Send it a different type of data and it will render the list accordingly. Then we have our property, and this is that detail screen that we see all the details. And then we have our items. Now this is the items modal, that pop-up that pops up to let me enter the details for the item and save it. So aside from components, we have assets. These are just the logo. We saw that thriftily logo at the beginning on the home page. And then we have our API. So let's look at the app.js. Inside of app.js, we have our imports at the very top, and then we have the body of our entire screen. Now this is the entire welcome to React screen. Alongside that, we have our style sheet. These are all the styles for the various fonts, the sizes, and all these hyperlinks and the coloring of those. But in reality, when you develop your React Native application, you want to separate this from your actual code, your body logic. You can see here with this home screen, for example, I have the home screen component and then I have the styles separated from the actual component. I'm going to go ahead and swap this code out with the code we had for our a home screen with that button. So one thing that you'll notice is I've swapped the code out and it's separated I've separated the entire styling. And what I'm going to do is with this code, once I save it, you can see VS Code shows me that it's not saved yet. You'll see that React Native will go ahead and refresh. This is what we call a fast refresh in React Native. What the fast refresh will do is it'll detect UI changes, and if it's possible for it to go ahead and update the screen, it'll go ahead and update the screen with the new UI changes that you see. So as you can see right there, it showed you refreshing, a little refreshing banner, and now I see the new screen. Now this is that screen we saw with the property list, and here is where my navigation will be. I have my navigation container, and inside that I have my stack navigator, and inside that I have my screens that I'm going to be navigating to. By simply setting it up as such, I'm able to navigate to whichever screen I want from whatever screen I'm at, and not have to worry about all the gesture logic, any kind of logic of how I'm going to navigate and whatnot. That's all being handled by this navigation library that's built in with React Native. So let's go ahead and move over to the property list screen. And let's pull up the code for the property list. Here it is. All right, so one thing you'll initially see here is I have these two static properties. Now, what I want to show here is the difference between me pulling that data from somewhere and having that data static and how the state can update. Right now, I'm using this dummy data variable that's an array of these two properties, right? But I also have this data variable that's empty. That's where I want to store all my other data that I'm going to be getting from my API call. That you can see right here inside of component did mount. Now what a component did mount is, it comes baked in with the component. If your class will extend a component, you'll have access to this component did mount. This is where you'll do any kind of logic when this screen comes into view. And inside here, I'm doing an API call to get my properties. Now let's go ahead and swap this dummy data out for the actual data, because the API call has already been done, so I should expect data to be there. And as you can see, the data is there and it loaded it up. So what happens here is, after I do the search locations, I grab the value and I do a set state. This is where that state management comes in, and components having their states as their memory. Me adding the set state and then passing in that value to that data component that's set up in the constructor for this class gives it whatever values or whatever data that it needs to use for my components. So when that happens, we see that the data all populates here. So now if I go back and I go to the screen, you'll see for a split second it's blank and then the data pops up, because what's happening is the component is mounting, it's making that API call, and then it's mapping the values of that property to this data. Now, what I want to talk about a little bit about this list is what you see here is inside of the safe area view, I have a list screen. This list screen takes in the data, which is either that dummy data or the data that I pulled from my API. And then it has a render item prop. This is where that whole property stuff comes in for components. So I have a data prop, I'm giving it the data, then I have a render item prop. Now this is a function, and what this function does is it takes whatever data that I've passed to the list screen, and it takes each little component. So we're assuming that an array is being passed. We're taking each index of that array, and we're going and rendering however we want to render it. In my case, I'm rendering a list item. And here in this list item, you see I have the title, description, and what's on the left-hand side, which is this home icon, and what to do if you press that list item. That's how lists work, and that shows props and states of components. What I want to see now, I want to go ahead and share with you guys now, is this search locations. Now the search locations is an API call. Let me go ahead and collapse all this data, all this code right here. And now you can see in my API utility, I have a few calls over here. So the one we see happening on the screen is the search locations call, which is pulling this location data. And before we go into this API calls, let's go ahead and look at the Thriftly's auto-generated documentation, because that'll give us a sense of understanding of how the front-end developer doesn't need to worry about what's happening on the back end and how the back end is working because the Thriftly's auto-generated documentation will help the front-end developer know what your models need to look like and know what those API calls, how those API calls need to function. So let's take a brief moment and look at that. All right, so taking a look at this Thriftly's auto-generated documentation for our property tracker endpoint here, we see that it gives us the location to where our endpoint is. It also shows whatever services are underneath this endpoint. As you can see, we have the location service, item service, and the product directory service, right? So in our case, we were looking at the search locations call in that properties list. I'll go ahead and click into the location services where I would assume that the search location is, right? So that's where it is. So we have our search locations call underneath here. And nicely with Thriftly's auto-generated documentation, under the service we see whatever other calls are there. We can also see whatever structures this service would use, and we can see whatever exceptions any call on this service would throw. So looking at our calls, search locations is the call that we're going to be using, right? So clicking into there, it shows us the body. So this is the parameter that the call will take when it's going to be when you do the post request. And then we also see the data type for that and if it's required or not. In our case, the data type is T location search criteria. So we don't know what data type that is, but nicely with Thriftly, it's a hyperlink. We go ahead and click that hyperlink and it'll take us to the structure and it'll show us all the required parameters inside of that structure, all the elements of that structure. And additionally, it'll provide us data types. These are data types that we're more familiar with. And it also shows us if it's required or not. Additionally, inside of that same call, we could see what this call will return. And we see that it's an array of T location. Another data type that we can click in and we could see what the elements of that structure is, right? So this is how I've modeled the property inside of our React Native code. Because of looking at this, I know what variables I need and what's the data type on those variables. That's how cool Thriftly's auto-generated documentation is for a front-end developer. We don't even need to worry about whatever the data type is on the back end. The auto-generated documentation will tell us that, and it'll tell us any type of variable that we should be expecting to come back. Cool thing about this auto-generated documentation and Thriftly's whole setup here is I could also test these calls without needing to implement the code or without using something like Postman to test them. I could test them straight from this interface here. So you have this test API button. I'll quickly click that and it'll launch me into this little test utility. Now here I could put in requests and I could see whatever response is. So in our case, we want to use these search locations. Here's the same body that we saw previously, that structure for the search location. I'm going to go ahead and delete some of these because none of them were required. So actually, I could delete them all and I'll still get a response with data back. But I want to go ahead and just get one unit of data back, as is right here. And this could easily help me as a front-end developer look at what my request should look like and expected response should look like, and I'll have a mindset of how I want to implement that in my code. Now, cool thing here is Thriftly doesn't just support this JSON RPC protocol. I can click down here and it'll show me a drop down of other protocols that I can use with Thriftly. Now, know that Thriftly is not limited to these three protocols. Definitely check out the Thriftly's actual documentations to know about more protocols, but these are the three protocols that we have on this test module here. Clicking on SOAP, you can see the differences between the JSON RPC and the SOAP. Now, in our case, in our React Native app, we're using JSON RPC, so that's what I'll be showing here. I can use JSON RPC, send in some parameters and see my expected response. However, right here, because I sent in a bunch of these strings, none of this is really going to match, so that's why it got hung right here. And you can see empty response, so it didn't get hung. So I'll go ahead and delete this and see my expected response. And that shows you how easily a front-end developer get their hands dirty without knowing anything on the back end and have your front-end application up and ready much quicker than it would take by learning the back end beforehand, right? So let's go, now that we've seen this Thriftly and this auto-generated documentation, let's go back to the app and look at the API and then start building more onto the application. All right, so getting back into the code, we see here in my API util class, I have 4 different functions. I have these 3 at the bottom, which are the actual calls to whichever endpoint. Now, what I wanted to highlight here is the API request. This function is the root function. Now, all these will go ahead and call this and pass in its parameters, and this is the one that will make the actual HTTP request. As you can see here, I'm using the fetch API. I have the endpoint that I want to send it, and then I'm also sending some additional parameters. And that's how this simply, I'll be able to do my HTTP request and get my response back. And in my response that I'm getting back over here, I'm mapping that response. My response is coming back as a JSON, but I want to go ahead and actually associate some kind of data type to it. So that response that API request library is going to send back to the search locations function, that's going to get sent back over here wherever the search location is being called. I'm using that, I'm taking that value and I'm mapping it. Now I know from looking at the Thriftly document, the auto-generated documentation, that I should be expecting an array of properties. So in my property map list function right here, what I'm doing is I'm mapping that JSON that's coming back to a property object. Now this property object is something that's set up based on the structure that I saw in the Thriftly generated documentations and all the elements that were inside of it and all the data types associated to those elements. In this function down here, I'm taking that JSON I'm getting back, looping through that JSON and mapping it to a property object. So that way it's associated with the data type, and that helps me with IntelliSense, so I can use the dot notation to know what elements that I can select from, and it actually gives it a data type that I know that, hey, this data type, I can do certain things with it. Now, aside from that, we have our list item, right? And now in our list item, it has it on pressed. So if I were to go ahead and press into one of these, I can see that it takes me to the details screen, right? So how does that happen is from here, this navigation logic that's happening here. Inside of the constructor of my class, I have a const navigations, and this thing is what we set up in each screen that we want to use navigation. In our case, I want to use it here in number property list because I'm moving to a details screen. Now, because I've already set up that whole stack navigation in my app.js, all I have to do is tell it what screen I want to pass to, want to navigate to, and then it'll navigate to that screen. I could easily change this to some different screen, and it'll go ahead and navigate to that screen from here. Here, I'm also passing in some parameters that that next screen will need or will want to use. So let's go over to the property screen. All right, so over here on my property screen, you see a couple of logical things happening here. So one thing I want to show you is when I go to the screen is mounted, I'm pulling from my props whatever property was sent over. As you saw before in my navigation, I'm sending over that property. And it's getting associated to this variable, this property variable that I set up in the constructor. Now, one other thing you can see, I have this callback over here. This callback is doing a couple of things for me. Once that property is being set, I want to do some additional functions. So what I'm doing is, one, I'm setting the header. This header is setting the title to that property name. And two, I'm making a call to get items. Now that I have the property set, I know I can access the ID of that property. Now I'm going to go ahead and do a get items call, and that's going to get me back all the items associated to this property. Now, how would we access those items? Before in the demo, you saw that there was a floating action button. However, you don't see that here. So let's go ahead and bring in that code for that floating action button. And one thing I'll show you during putting this code in is how React handles where stuff goes. In our case, let's go ahead and put it right underneath the details, right? So once I paste it underneath here, you'll see that the floating action button is not in the bottom right-hand corner as we saw in the demo, but it's right here next to the details, because that's as much as the details expands. Now, if I were to add more details, it'll get moved down, but that's not what we want. Another thing you can't see here is it's associated with the scroll also. I don't want that. I want it to be stationary regardless of where I've scrolled up or down. I want it to just stay there. And that's, I can go ahead and move it outside of the scroll view. And now that I have it outside of the scroll view, it's on the same level of the scroll view, but it's not inside the scroll view. Before, being inside the scroll view on the same level of the edit view, it was going to be associated with those and scroll alongside it. Now if I save it, it's still there, but it's not going to scroll alongside those. Now that's how React is going to is handling my floating action button. It's putting it on the same level with whatever is also on that level as a stack. It's stacking it on top of each other. But I don't want that either. I want it to be on the same level of everything. I want it to be on the root, the highest level I can possibly put it on. And that would be achieved here on the outermost. Putting it here throws it down into the bottom right-hand corner, and it's not even associated with the scrolling abilities. Now, if we go ahead and hit into this, we can go ahead and see that I have my show items, and that's the next screen that I'll get navigated to now because I've already pulled in my items. So if I click show items, I'm on the items screen. Let's go ahead and go back. Another button here is the add item button. I'll go ahead and click the add item button, but you see nothing happen. Well, that's because we don't have the code or the logic for the modal to happen here. Now, I'm importing the modal up here, but I'm not using the modal down here. That's what I want to go ahead and show here is the modal, as we saw in the demo, should be all over everything, even over the floating action button. And this will reiterate what I meant by what the whole levels of these components and how React is going to stack them on top of each other. So I have two components inside of this these brackets right here, this bracketed group here, right? So I have my safe area view. Inside the safe area view, I have various other components such as my details screen, right? And then on that same level, I have my floating action button. Well, additionally, I want to put on the same exact level my modal. Now, my modal, if we go ahead and take a look into it, it's a function. And there's some logic happening here, and then I have my body of my modal. So how do we use functions as components? To do that, we can go ahead and put in some brackets here, and we can call that function and pass in the parentheses. Now, this is only possible if that function is returning a component. That way we can go ahead and call that function right within our component group or component list. So in our case, we see the modal is returning a modal component, right? So therefore we can call it. So we're going to go ahead and let's go ahead and pass in whatever parameters that it needs. All right, so that should help me use the modal. I'll go ahead and save it. You saw that refresh. Let's go ahead and try clicking it. And voila, there you go, it works. So now I can click outside the barrier and dismiss it. And now we're getting close to what we had in that demo application. Now that we have the modal, one final thing that we need on this screen is we need more details. We don't want to just see these two details. I want to go ahead and add some more details. So let's go ahead and take a look at the property edit views whole detail screen. Here you can see I'm calling a function called text input line, passing in its parameters. That's the same thing we saw over there with modal. I'm calling it as a function, and because I know that it's expected to return to me some components, I could go ahead and call it inside of these brackets. But let's go ahead and add some more details. Now you see that I've added more details. Now, one thing I want to show you here is I added these details, and I should expect it once I save it to refresh and show me these details. So I go ahead and click save. It refreshed, but I don't see any changes. That's because this component is mounted and it can't call any more functions. What these are functions. They're being called when the component mounts so they can go ahead and render on the screen based on whatever property is passed to them. The only way I could go ahead and get these to show on the screen is if I reload the application. And I'm going to show you guys a real quick and easy way to do that from inside the app. So if you take your phone, your device, and you go ahead and shake it, you'll be presented with this debug menu. Now, before we go ahead and use the reload function in this debug menu, let's go back to the slides and take a look at some more debugging tools that React Native provides us. Okay, so back on the slides, we have a few different debugging tools and methods we could use with React Native. One that we just saw is the in-app developer menu, and we'll use it when we go back to the code. Now, what we've been seeing is as I've been adding code, a fast refresh has been happening. That's what helps us, change some logic in the code or change some UI elements in the code. Go ahead and save that file and see the difference happen on on screen with our application. Something else we have are in-app errors and warnings. Now, in-app errors will be a big red banner that comes up and tells us what the error is, and that'll take up the entire screen on our application and not allow us to continue with anything else until we fix that error. Warnings will show up as in little blue, little yellow banners at the bottom of the application that we can look into, and they won't disrupt any usage of our application. Now, a cool thing we could do, because this is a JavaScript JavaScript framework, we have access to the Chrome and Safari developer tools just as we do any other JavaScript framework. Now, from our in-app developer menu, we can go ahead and start the remote debugging, and we could go to our Chrome developer tools, go to this URL, and we be able to interact with our application using the Chrome developer tools, such as use the console, use the network, monitor some performance, heck, even check the elements. Now, additional to the Chrome developer tools, we have the React developer tools. These are exactly the same as what Chrome and Safari's developer tools provide. However, the React developer tools will have some extra goodies for React specific stuff. Now, you can get away with using the Chrome developer tools because you might not need any of those extra goodies, and you'll be able to, the Chrome developer tools will be sufficient enough to help you develop and debug your application. Now, another thing with React Native itself is because it is native, a native application is being created, you also have the advantage of using Android Studio or Xcode to look at those native logs for each specific platform, such as on Android, we can go into Android Studio and monitor logs there that are Android specific. This will allow us to look at even more in-depth error handling that, hey, like some problem that we can't figure out by simply using the Chrome developer tools, or the errors or warnings aren't giving us sufficient amount of information, and we want to go into some native logs. We can do that by using like Xcode on iOS to look at and monitor the logs for our application. So these are a few debugging tools, and now let's get back into the application and actually use the in-app developer menu. All right, so from our in-app developer menu, we're going to go ahead and click reload. Reload is going to go ahead and grab the application and all this data for this application back from the base. So we'll see it go back all the way to the home page. So clicking reload, it's going to go ahead and grab all that data, and now I'm presented back to the home page. Now if I were to go to the property details screen, and voila, we see more details. And this is how simple React Native is. We have our components, we have our navigation, and we have our API calls. And by simply knowing JavaScript, being able to understand how these components work, we could develop and make brilliant applications. React Native is used by big companies, and it's been around since 2015, so there's a big community support for it. Now that we've had our code put in, we could see that this application looks identical to the demo application that I showed you. We have our list screens, we have our buttons and our modals and all that functionality, all that good functionality. So now let's go back into the slides and wrap it up and see why we want to use React Native versus any other framework for mobile development. Okay, so to answer the question of why we want to use React Native, well, one answer is dead simple. It's the ease of learning. React Native is nothing but a JavaScript library, JavaScript framework. And being JavaScript, anyone who knows and understands JavaScript can come in and learn React Native and be able to get up and running real quick. Now, the benefits of React Native is it's truly native. Even though you're writing JavaScript code, it'll get compiled down into native actual code for the iOS or Android platforms. Now, with that whole JavaScript aspect, it comes with a vibrant ecosystem. JavaScript has all these third-party libraries that have been developed for it, so you can use those libraries to your benefit. Such library would be Moment.js for date time manipulation. It's a JavaScript-only library. Because React Native is JavaScript, that library can be used alongside React Native and compiled down into a mobile application. Another cool thing that we didn't really go over is TypeScript support. React Native supports TypeScript, and TypeScript is something you've seen with Angular. Although throughout the application we developed, we only used JavaScript, TypeScript is also supported, and if you know the benefits of TypeScript, you know why you would want to use it. An addition is I showed you a iOS application, but React Native is truly cross-platform, and I can go ahead and demo real quick that same application that we just developed, compiled down, and working on an Android phone. All right, so now you can see here, this is the same application that we developed. Mind the quality, I'm using a different screen recorder for this. Now, this application looks identical to what we just developed, but you could see the difference when I click this button to navigate. See how the screen came up from the bottom to the top? And you can see how the app bar is different, how the properties is aligned to the left-hand side, and the whole back button is different. It doesn't have the naming on it also. And even when I move into a different screen, you can see how it slides up from the bottom. You can see that the floating action button is actually identical. The modal that comes in from the bottom is identical. However, the navigation is different. The header bar is different. And that's because this is Android specific. And you will see that Android doesn't even have the slide gestures. I can't slide in, but I can click the back button over here to go back, because Android's back button comes in from either a left or right side, as you can see coming in from there. And that's really quickly that this is the same application that we walked through, also working on Android. All right, so to conclude, I just want to reiterate how easy it was to develop a React Native application and how the code is just simple JavaScript. And we saw how Thriftly's auto-generated documentation can help us as a front-end developer know what the request should look like, know what the response should look like, and even shows us the structure. So I was able to quickly make that model in my front-end code and be able to be ready to go to make those API calls with React Native's built-in fetch API. So I don't have to create a separate service as I would in Angular. And that really shows how simple and easy React Native is, just by simply being a JavaScript framework and also compiling down to native code. We saw how it looks on iOS and saw how it looks differently on an Android device. Now, I'll go ahead and pass it over to Oliver, who'll finish up, and then we'll get to some questions and we'll answer those for you guys.
Thank you, AJ, for showing us around React Native. That was a really nice overview, and I'm certain it'll help people get started with it. While you were doing that presentation, I actually wrote down a few questions that came up. I was hoping we could spend a few minutes to do a short Q&A to maybe get some answers to those things.
Yeah, for sure.
The first question I had is really in relation to some of the limitations that may be there for React Native. I know normally in JavaScript, when you're in the browser, there's quite a few limitations. Mm-hmm. Are those same limitations going to be in place when you're using JavaScript with React Native?
So yeah, definitely. React Native is a JavaScript framework, so any limitations that you've seen in JavaScript will translate over to React Native. However, because it's compiling it down to a mobile application, you might not see those browser-specific issues unless you're using a web view. So that's one difference with React Native, because it's going to compile down those JavaScript code into components. It's probably not going to show you those browser-specific limitations you've seen.
So I know, like in the browser, for instance, it's very common to have pretty tight restrictions on network access to prevent things like cross-site request forgery, CSRF, and things like that. Are you going to have those limitations in React Native?
So yeah, if you've seen those limitations in the browser, they will be present here, but those aren't handled by React Native. Those limitations are going to be handled by the platform itself. So on iOS, you will definitely need to go into the configurations of your application and allow the HTTP requests. On Android, I know for a fact that they don't allow clear text traffic, so you'd have to mess around with the configuration files. So those kind of limitations aren't on React Native as much as they are on that specific platform.
Gotcha. Okay. And what about access to things like Touch ID and Face ID? Are you able to use those with React Native?
Yeah, definitely. You're allowed to access those sensors. As long as Android or Apple has created an SDK, you should be able to access the sensor. And there's probably already some community-driven components out there that'll allow you to have those sensors used. But if not, you could definitely go in and write some native code for those platforms and bridge it over to React Native.
Gotcha. Okay. Now, when we talk about this whole cross-platform environment, I know that on Android versus iOS, there are some things that are even ideologically different. You know, there's some big differences there. How do you handle those differences where things are just not even implemented in the same way between both platforms?
Yeah, so definitely some components have already taken this into consideration. So if you were to use native components that come built in with React Native, those are already going to be considering those differences and have those implemented properly. And if, let's say, you use some third-party components, they might not, they might just like get away with it. But yeah, definitely, as we've seen in my demo, we saw how the navigation is different. On Android, you see the navigation, the screens change from bottom to the top. That's how the transition happens. While I was on iOS, the transition happens with the screen sliding in from the side. And definitely another thing with navigation is swipe gestures. On iOS, everybody's comfortable with applications and you swiping back to go to the previous screen. Whereas on Android, that just doesn't exist. And the React Native component, that library, has that into consideration and takes care of all that for you.
Good to know. Now, we were looking at this for of course, a mobile platform, but the name React Native doesn't really seem to imply anything that means that it's mobile only. Can you create React Native desktop applications?
So in a sense, yes. So you can port over the applications you have created for the mobile platforms. Microsoft and React Native have gotten together and they've built the React Native Windows framework. So what that allows you to do is bring over your React Native applications. However, you might have to consider some sensors not working. So let's say if you're trying to access the camera, there might be a different way that access is on a desktop. So your concurrent components that let you access the camera might not function. But yeah, definitely using the React Native Windows framework, you can use and develop React Native applications for desktop. And if you do on Windows, you can have those same applications work on Xbox and Surface tablets.
Gotcha. Okay. Well, that's good to know. Now, I know within Mertech that we've standardized pretty much across the board on using MacBooks for our development. If one of our listeners or individuals watching today, if they're going to develop with React Native and want to work on an iOS app, do they have to have a Mac to do so?
So the answer to that question is kind of yes or no. Yeah, you can create and develop your React Native application on whatever platform can run the React Native framework or handle the React Native framework. But to actually test and build the release application for iOS, you will need access to the Mac operating system. The reason being is to build the application, you need Xcode, and Apple only provides Xcode on their Mac operating systems.
Gotcha. Okay. Well, good thing to know. Thank you for taking a few minutes to talk to us today and for your wonderful presentation there. I know it'll be helpful for many, and hopefully it'll drive some of them to get started building their first mobile application using React Native.
Yeah, definitely.
I wanted to go back to our slides for just a minute and share with everyone some resources that we're making available. There will be a PDF version of our slides that have links to the application that AJ created here, Git repo, where you can download that and play with it yourself, along with a tutorial on getting started with React Native. And of course, we have links there to get started with Berkeley Developer and some of the tools that AJ mentioned are used in his presentation as well. Thank you so much for showing us around React Native today, AJ.
Yeah, no problem. Thank you.
And thank you to everyone for joining us. Next time, we'll be talking a bit about security in relation to your APIs. So please stay tuned for part 4 of our webinar series on hybrid cloud applications.